Hello everybody, this is adding vectors together. In a previous video I have stated that a vector is a quantity that shows both magnitude and the direction, so two things. So the size or the magnitude of the vector matters, so does the direction that it's pointing to. A scalar, just the magnitude matters, so this is 5.5 inches for example. The direction does not matter. The magnitude stays the same no matter how much I move this, and it's a scalar quantity. But if I want this as a vector, like this is velocity, let's say this represents 5.5 miles an hour, then the direction that this is facing indicates, well in this case, north. So that's what vectors are. They show two things, whereas scalars show one thing. So when you add two vectors together, let's say vector A and vector B, now this isn't really to scale according to the graph that I drew. When you add the vectors together, these are perpendicular to each other, meaning that they create a 90-degree angle here. So furthermore, you can't just add them up consequently. Well, when you work with adding vectors together and creating perpendicular angles, you're going to have what's called a resultant vector. Now you might say the magnitude of the resultant is going to be Pythagorean Theorem. Well, that's half right, but you have to set something up first. Vectors have to be in a head-to-toe fashion or a head-to-tail fashion or manner, depending on what your teacher and or textbook uses. I have said that moving vectors or sliding vectors over does not matter because it retains its magnitude and direction. So if I were to move vector A and slide it over here, is that perfectly alright? Absolutely. And as a visualization, imagine this pen here representing vector A. I could slide it over so that the head of one vector meets the tail of the other vector. And is this still 5.5 inches? Yes. Is it still facing the same direction? Yes. So it's perfectly alright to move vectors. You could also move vectors this way to get a head-to-tail fashion as well. So let's move vector A over here, and this is the same thing. So let's redraw this and have vector B in the x direction this way. Now vector B is going to be 4. So never mind about the units right now. Okay, I'll just put inches. And then vector A, so this is more like a scale model instead of a... Okay, this is going to be 3 inches. Alright, so now since we're at a head-to-toe manner, now what about the resultant vector? Okay, now the resultant vector, would it point this way or that way? Well, this is going to be where you start at because there isn't an arrow pointing in the opposite direction here. Since there's no arrow, this is where you're starting at, and it's saying that you went 4 inches this way and 3 inches that way, and this is where you ended up at. So you always want to go from the origin where you started at to where you ended up at, and that is called displacement. So I'm not really going to totally define a runaway pencil. So this is going to be your displacement vector. We call that vector R. Okay, and to find vector R, we just simply add, well, this is the formula to it, we just simply add A and B. Now, I'll explain. So vector R equals vector A plus vector B. Notice I say this is vector A plus vector B. It doesn't have anything to do with the magnitude of vector A and the magnitude of vector B. If you want to find well, I'll get to that when I get to it. So what is vector A? It's right here. and its magnitude is 3 inches. Okay, but what about the direction? The direction of vector A is totally perpendicular to vector B. So we can't say that these two are going in the same direction. So since this is going to the y direction, we say y hat or j hat. You could use j or y. Vector B is going to, the magnitude is 4, and it's going into the x direction, or x hat, or you could also say I hat. So this could be I or x, this could be j or y, and there's a little caret symbol here. Generally you'll see it as where the I or the x is first, and then the j is last. It just means 4 units to the x direction and 3 units in the y direction. We aren't going to do subtracting vectors, but if they go into the opposite way, so if it's left or down, then it's going to be there's going to be a minus sign. So if this vector B was going in the opposite direction, the same magnitude, it would be minus 4 inches. When a vector goes either to the right or up, then it's going to the positive direction. So this is actually the answer right here. This is what vector r equals, but it's probably not what you expected. You're thinking about a single number, weren't you? So the magnitude of vector r, I think sometimes it's like 2 lines, but it's sort of like an absolute value sign, or sometimes it's just r without the arrow above it. It means magnitude, but I like it this way. So basically what the magnitude is the distance here. Okay, this is a distance. How do we find this distance? Remember the Pythagorean Theorem that says, that would say a squared, vector a squared plus vector b squared equals vector r squared? Okay, well, that's exactly what this length is going to be. You use Pythagorean Theorem to find vector r. Instead of saying like vector r squared plus that and doing an extra step, you could just automatically just put square root sign a squared plus b squared, and of course the magnitude of these. So from here you just plug in what's the magnitude of vector A. It's 3, so it's 3 squared, and the magnitude of vector B is 4 squared, all under a square root sign. Okay, that's 9 plus 16, which equals root 25, and which, since distance is always positive, 5 inches. So that's basically our displacement is 5 inches right here. And that is the answer, and that is the basics of how you add vectors. Okay, so thank you everyone. I'm not going to ask you to like or subscribe. You could if you want to. I'm just passionately doing these videos from my heart. I'm not calling any of my videos perfect or ideal, relatively speaking. This is, besides, this is merely a fraction of a 0.25% of all the myriad of videos out there concerning this subject, including videos with more easy to understand animation and explanation. I'm simply one voice out of many. My passion is to help and teach others, and so this is a great way to implement this zeal while gaining positive feedback from the community. Thank you very much for your time.